Hey, what's happening, guys? So today we're going to be going over the force velocity curve. Not too complicated, but something that's really important to understand when designing your own training program. So we have three main areas we're going to focus on: concentric, isometric, and eccentric. And these are different muscle contractions. So concentric is when you're shortening of the muscle, isometric is when it's staying in one spot, eccentric is when you're lengthening, all under tension. Let's go over the concentric part first. So what this is basically saying is when velocity is very high, when you're moving really quickly, shortening, there's not going to be a lot of force. And that makes sense, right? Like if you have a really light weight, you can go very quickly. On the other hand, if force is high, velocity is low. Again, this makes sense. If you are holding really heavy weight, you're going to be moving slowly when you're concentrically contracting, right? So this makes sense. On the other hand, when you're isometrically contracting, force is maxed out. This is actually the definition of strength, right? Maximum force you can produce. But when you're isometrically contracting, there's no velocity. Again, this makes sense. It's like a plank, you know? You're not really moving, or you aren't moving. And then you have the eccentric. And this is saying as you're lengthening, as velocity goes up, force goes up. Now, how does this relate to designing your own training program? Because training is really specific. The stimulus you put on your body, the exercises you do, they will cause very specific adaptations. So you want to make sure the things that you do transfer over to your goal. For example, let's say your goal is to jump maximum height, right? The force would be your body weight. Let's just say that's around there. And a vertical jump lands somewhere in the middle here, right? A clean and jerk or a snatch, that's a little bit higher up. There's more forces involved, but still a good amount of speed. A 1 rep max back squat is all the way up here. There's not a lot of velocity, and velocity is not the limiting factor. So let's just say, for example, you want to increase your vertical jump. You know that lands somewhere around here on the force velocity curve. And if you train a 1 rep max back squat, that's all the way up here. It's not that specific, you know? Even though the muscles used are the same, the range of motion can be the same, the force velocity, like they're too far apart, you know? So that's why in the beginning, you might get great gains. Like if you start doing the 1 rep max back squat. In the beginning, sure, your vertical jump will improve. But later down the road, it won't transfer because they're too far apart on the force velocity curve. So the main way to use this in designing your own training program is to know what your goal is, where it lands on the force velocity curve. And your training, is it too far away from it? For example, like for badminton, right? The racket is very, very light. It'll probably be somewhere down here, right? If I practice doing dumbbell raises with like 30 pounds, that's all the way up here, right? And the motions aren't, well, there's a couple of problems with that. The motion isn't that similar to a badminton swing where there's a lot of rotation. But let's just say, for example, the motion was similar. The weight is so heavy, the velocity is so low, it doesn't transfer over, right? Now, eccentric, this is very interesting because on this side, this is the only part of the curve where you have high forces and high velocity. So what kind of exercises are these? These are, for example, depth jumps, like when you jump off a box or when you sprint downhill. That's like overspeed training. That's really high force, very high velocity. The problem is that's like the most dangerous type of training, right? Like if you're sprinting downhill, if you're jumping off like a 5-foot box, yeah, you're going to get really high levels of activation. There's going to be high forces, high velocity, and it's all eccentric, right? The muscles being elongated under tension. Yeah, you know, that's all eccentric, high forces, high velocity. It can get really good results. You just want to be careful with the safety of it and like how fast you progress it, how much you do, because that's definitely the most dangerous type, right? And obviously isometric, if your goal is anything with velocity, isometric is the least specific, right? There's no velocity in that. So if you're trying to become a really good sprinter, doing isometric training for your core could help because, you know, that has to stay very tight. But doing isometric training for your lower body, like your legs, it's not, I mean, again, you know, if that's a very undeveloped area, then yeah, doing some training will help. But if once you're like past the beginning stages and you have some growth in that area already, going further down that path, it's not specific enough. So it's not going to give you the most bang for your buck. It's not going to transfer that well. So just remember, when you're doing force velocity curve, step number 1, figure out what your goal is. Where does it land on this curve? and all the exercises you pick should be close to that. So let's